Welcome to the first year of chemical engineering. This tutorial will give you an overview of what you will learn in your introductory courses and the prerequisites you need to succeed. Chemical engineering is a diverse and dynamic field that combines principles from chemistry, physics, mathematics, and biology to solve problems related to the production and use of chemicals, materials, and energy. In your first year, you will cover topics such as basic chemistry and chemical reactions, thermodynamics, fluid mechanics, heat transfer, material and energy balances, and chemical kinetics. Understanding chemical reactions is fundamental to chemical engineering. You will learn about atomic structure, the periodic table, chemical bonds, stoichiometry, and different types of chemical reactions. Thermodynamics is the study of energy, heat, and work. Key concepts include the first law of thermodynamics, which deals with energy conservation, and the second law of thermodynamics, which involves entropy and spontaneous processes. You will also learn about enthalpy, denoted as H, which is the heat content of a system, and Gibbs free energy, denoted as G, which determines the spontaneity of reactions. Fluid mechanics involves the study of fluids and their behavior. You will learn about fluid properties such as density, viscosity, and surface tension, as well as different types of flow like laminar and turbulent flow. Bernoulli's equation describes the relationship between pressure, velocity, and height in fluid flow. The equation is P plus 1/2 rho v squared plus rho gh equals a constant. Here, P is the pressure, rho is the fluid density, v is the velocity, and h is the height. The continuity equation, which is A1V1 equals A2V2, describes the conservation of mass in fluid flow, where A is the cross-sectional area and V is the velocity. Heat transfer is essential for designing equipment like heat exchangers and reactors. You will study conduction, which is heat transfer through solids, convection, which is heat transfer through fluids, and radiation, which is heat transfer through electromagnetic waves. Fourier's law describes heat conduction and is given by the equation Q equals minus K nabla T. Here, Q is the heat flux, K is the thermal conductivity, and nabla T is the temperature gradient. Material and energy balances are used to analyze chemical processes. You will learn to set up balance equations for mass and energy, understand steady-state and unsteady-state processes, and use techniques like recycling and bypassing to optimize processes. Chemical kinetics deals with the rates of chemical reactions. You will learn about rate laws, which describe the relationship between reaction rate and concentration. The rate law is given by the equation rate equals K times A to the power of M times B to the power of N, where K is the rate constant, A and B are reactant concentrations, and M and N are their respective orders. Activation energy, denoted as EA, is the minimum energy required for a reaction. The Arrhenius equation describes the temperature dependence of reaction rates and is given by K equals A e to the power of minus EA over RT, where A is the pre-exponential factor, EA is the activation energy, R is the gas constant, and T is the temperature. To succeed in your first year of chemical engineering, you should have a solid foundation in mathematics, chemistry, physics, and computer skills. Mathematics is crucial for understanding and solving engineering problems. You should be comfortable with algebra, calculus, linear algebra, and differential equations. A strong background in chemistry is essential. Make sure you understand basic concepts like atomic structure, the periodic table, and chemical bonding. You should also be familiar with different types of chemical reactions and stoichiometry, as well as thermochemistry, which deals with energy changes in chemical reactions. Physics principles are applied in many areas of chemical engineering. Key topics include mechanics, which involves force, motion, and energy, thermodynamics, which deals with heat, work, and energy transfer, and fluid dynamics, which studies the behavior of fluids in motion. Basic computer skills are necessary for simulations and data analysis. You should be familiar with using spreadsheets, such as Microsoft Excel, and have a basic knowledge of programming languages like Python or MATLAB. This tutorial has provided an overview of what you will learn in your first year of chemical engineering and the prerequisites needed to succeed. By mastering these topics and building on your foundational knowledge, you will be well prepared for the challenges and opportunities in this exciting field. Happy learning! Thank you for watching this tutorial. We hope you found it informative and helpful. Good luck with your studies in chemical engineering.